Hi guys, welcome back. So in this video we are going to do the practice work of multiple logistic regression. So the activity of the day. These are the three flowers as you can see. Versicolor, Virginica and Setosa. In this activity, we'll have to predict the three categories of iris flowers data: the versicolor, virginica, and setosa, based on the basis of the sepal and the petal length and width. So the so here is sepal with centimeter, petal with centimeter, sepal with centimeter, and petal length centimeter are independent variables. And species is a target column that consists of these three categories of flower. So let's get started. The first step, to load and inspect the iris dataset. We're gonna import pandas as PD. The how to read a data. Data is equal to pd.read underscore csv. We're gonna check all the operations on the left side. Means head for first 5 rows. We're gonna print the shape for the dimension. What else? We're gonna print the column names, columns. We're gonna print the d types, and is null.sum to check if there is any missing value, and if there are, how many. And unique values. I forgot to add one more thing. So data dot column is equal to, remember to give a square brackets and the inverted commas. Sepal width, comma, inverted commas, and sepal length. We're gonna do the same thing for petal. Petal width and petal length. And with the last inverted commas, we're gonna write species. So now let's copy paste this all on our Google Colab notebook. We're gonna run it. Mm, okay, I think we'll have to add S over here. Yes. So we have our data. So this is the sepal length, the width, the sepal length, the petal width, and the petal length. And these are the species. This is the index. And so let's get started on to our next step, which is gonna be data preprocessing and feature selection. We are now going to do the conversion. Here we're gonna write replace here is gonna be iris setosa will be 0. So then iris virginica will be 1 and iris versicolor will then be 2. We want this to be permanent. So we are gonna write true without inverted commas. Till you see true is blue highlighted. Here it's gonna be values. Here it's gonna be species. We're gonna print X and we are gonna print Y. Now we are going to import the train test split. So sklearn dot model underscore selection, we are going to import train test split. We're going to divide the data into training and the testing, and we are going to print their shape. This part is not really necessary, so no need to do that. X capital train underscore train, the y small y underscore train. So if we have a small y over here, then why do you have a big Y over here? Of course, there will be an error showing up that this is not defined. So we need to make them the same. So I'm just gonna make them the small y. So here, it's, so x train, x test, y train, and y test is equal to train test split. In brackets, we're gonna write capital X and y. The test underscore size is gonna be 0.20. Means we're gonna take 20% as a test site and 80% as the training data set. So after we're done with this code, we're gonna copy it up in our Google Colab notebook. There is a key error. Right. So here we wrote sepal width, sepal length, and petal width and petal length, right? Here we wrote something different. So we will need to make it the exact same thing. So let's change it. Okay. Now we're gonna run it again. And here is our output. This is the output. Well, we're not fully done yet. Now moving on to the next step. That is model training and evaluation. Now what are we gonna do here? We're gonna import the library from sklearn.model import logistic regression. So we're gonna make a variable called softmaxreg, which will be equal to logistic regression. For example, here you aren't just gonna write logistic regression over and over again. For that, we created a variable that is softmaxreg. The multi-class is multinomial. We don't usually do this for logistic regression. We use this for multiple logistic regression. We now we want logistic regression to fit x and y. We're gonna predict for the x test now. So we're gonna create a variable ypred is equal to softmaxreg dot predict x test. That's how we're gonna predict the x test. And then we're gonna print the ypred. Okay. Now we're gonna Now, from a book called sklearn.metric, we're gonna open the page accuracy score and import it over here. So, from sklearn.metric, import accuracy score. Why do we need to import accuracy score? Because we want to check the accuracy of multinomial regression. So, so print accuracy underscore score y test and y pred. We're gonna predict the probability means the possibility. So we're gonna print softmax red dot predict proba. What does it do? Predict proba is the same thing as predict, but it's used for multiple logistic regression. And we're gonna have all these values. We're gonna predict it now. And now we're gonna predict for a single value. So print softmax red dot predict. See, there's no predict proba. So predict proba is used for multinomial regression, while predict is used for logistic regression. So after we're done with the code, we are going to copy paste it in our Google Colab notebook. Okay, one problem. It's supposed to be linear model. Don't forget that. So sklearn linear underscore model, because sklearn model is not a book, and we can't get logistic regression there, because if you want to find a page of the book, you need the correct book to get it. So if our library or the book is not correct or it's not found, then how are we gonna get the page from it? So this is so we're gonna fit x and y, and this is the prediction for the x test 100101. And now we're gonna print the accuracy score of the y test and y pred, which is 96, 0.96, 6, and so on. Now we're gonna predict the probability for multiple logistic regression. We have all these values, and our output is 0.97, 0.019, and 0.0033. Which one do you think has the most accuracy score? Of course, it's this one. And the least accuracy score is this one. Now, 0 is for this one. 0 is for the prediction for the single value. Now, using all of these, we are moving on to the last step. Data visualization means to plot the graph. Don't forget to import the matplotlib.pyplot library. Well, now we're gonna plot the graph, because matplotlib.pyplot is responsible, means it's in duty. So, so x and the column 0, y is equal to 1, x column 1, y equal to 1. The label is G, means green, and the label is Iris virginica. We're gonna do the same thing, but over here, like y is gonna be equal to 0, and over here to y is gonna be equal to 0, and R means red, label will be Iris setosa. Now we're going to plot the legend. So plt.legend lock upper left font size 14 means we want to set the setting of the text. Now we're gonna show the plot. After we're done with this, we are going to copy paste it over here. Right. Remember small y. We need small y. So here is our output now. So this is 2.5, 3.5, and our Setosa has the bigger petal length and and bigger petal or sepal length or width, as you can see it over here. While Ars virginica has a smaller petal length. So thank you so much for watching this video, guys. I really appreciate it. So don't forget to subscribe, like, smash the bell button, and share it with your family and friends. I'll see you in my next video. Bye.